Hello, everyone. My name is Mizael, and I'm the operations manager here at Blue Box for the U.S. Central Region. Today, we're going to walk through everything you need to know about your Blue Box system, what's inside, how to set it up, and how to operate it effectively. By following these steps carefully, you'll ensure your treatment runs smoothly, efficiently, and without any unnecessary problems. Here in front of me, you can see your Blue Box system exactly as you receive it when it arrives. Before we dive into the setup, let's start by taking a look inside and reviewing each item included. I'll explain the role each component plays and how it fits into the overall Blue Box process. Understanding what's in your kit and why it's there is the first step towards a successful treatment. Let's start with your extension wand and shooting tip. This wand can extend up to 10 feet, making it perfect for units where access is limited. This L-shaped shooting tip connects directly into the 1/4 inch push connect at the top of the extension wand. Next, we have your stir paddle. And this is what you'll be using to mix the enzyme into the water. It's important to achieve an even mixture. So be sure to stir thoroughly and scrape the bottom of the box to ensure all the enzyme is evenly mixed. You'll also find a 25-foot extension cable with 3 built-in power sockets. This will be used to power the compressor for your Blue Box system, giving you the flexibility to work in a variety of locations. Also included is a breathable motor cover. This is designed to protect the intake side of the motor, particularly in systems where there's minimal distance between the coil and the motor itself. Now, to help that motor cover stay in place, we've included 2 bungee cords. And now we have your 1/2 inch water draw line. This line transfers the solution from the Blue Box into your manifold and eventually onto your coil. This is your wet bag. Its purpose is to keep components that may hold small amounts of water from coming into contact with sensitive equipment like your compressor during storage and or transport. Inside, you'll find your 20-foot clear shooting hose. This serves as a delivery system for the foam, moving it from the Blue Box to your shooting wand. You'll also find a 25-foot water hose. This is used to refill the Blue Box system with water during operation. Additionally, you will find a 10-foot 1/4 inch compressor line, and this will be used to connect the compressor to the Blue Box system. And finally, we have your 1/3 horsepower compressor. This is the heart of your foam creation process. It provides the air pressure needed to actuate the pump and generate foam inside your Blue Box system. Now that we've reviewed all the components, let's go step by step through setting up your Blue Box system for operation in the field. As you can see, I have laid out all the components we discussed in the last session for easier access. First, we'll begin by inserting your 1/2 inch water draw line. And you do want to have this angled down to the bottom left of the box so you ensure that you are collecting all of the full solution. Next, I like to connect my compressor. I will be connecting it into an extension cord that's already plugged in, so I will not be utilizing the one in our kit. Same thing with our water hose. Next, I like to go ahead and connect my compressor tube. This will be going into the 1/4 inch port on the manifold. Next, we're going to go ahead and set up your wand. So first off, go ahead and grab the L-shaped shooting tip, insert it into the 1/4 inch port on the shooting wand. Open up the wet bag and retrieve the shooting hose. This will be inserted into the 3/8 inch port, and then the opposite end will be inserted into the bottom of the extension wand. Now we'll go ahead and fill up the box with water. Now the box has reached the optimal fill level indicated by the 2 screws visible on the front face. Remove the hose and we'll add the enzyme solution. Here is our standard 6-ounce packet of enzyme. This packet is formulated to fully saturate the amount of water currently in the system. Using your stir paddle, we're going to mix the solution thoroughly, and as mentioned previously, be sure to scrape the bottom to loosen any enzyme that may have settled. And that's it. Your blue box is now ready to shoot. This section outlines the proper installation and removal of the breathable motor cover, designed to protect the system's motor from moisture while allowing ventilation. To install, position the cover evenly over the motor housing and secure it using the integrated drawstring cord, ensuring a uniform seal. For smaller motors, use the included bungee cords to provide additional retention and prevent shifting during operation. To remove, release the drawstring, detach any bungee cords, and lift the cover clear of the housing, taking care not to damage the material. In this section, we will demonstrate the standard application of foam to the system's coil and provide a clear visual of the foam as it moves through the coil structure. Since this unit has already been pre-treated, the procedure begins with the direct application of a thick, uniform layer of foam across the coil face. Care is taken to ensure consistent coverage by overlapping each pass, beginning the next line where the trailing edge of the previous application ends. In this demonstration, the foam is pulled through the coil rapidly. In field conditions, this rate may vary, particularly if the coil is heavily obstructed. This unit is also equipped with our automated enzyme injection system, which, as shown here, applies the enzyme solution at preset intervals to enhance performance and maintain coil efficiency. In this next section, we'll be discussing how, when, and why you should utilize tarping during your blue box treatment process. During treatment of heavily fouled units, you may run into spots in the coil where airflow is limited due to increased local fouling. When this happens, you can utilize tarping to reroute airflow right into these stubborn areas. That extra push can really speed up how quickly the enzyme solution works its way through the coil. First, I'm going to apply a thick layer of foam on the problem area. As I'm applying, watch the foam and the way it sits on the coil. If you see the foam sitting on the face of the coil like this, without being pulled through, that's a sure sign that the airflow is limited in this area. Normally, you will see the foam retreat into the coil due to the system's airflow. This is where tarping comes in. It lets you focus airflow right to where it's needed the most, so the blue box system can do its job faster and more effectively. For now, we will let the solution on the coil work its way through. Once it's done, we will come back and walk you through exactly how to tarp the coil itself. Now that the solution has cleared, let's run through the same procedure. However, this time we will be tarping 50% of the coil surface to push more airflow through the troubled areas. First, I will once again apply a thick layer of foam to the coil. Notice again how the solution is staying on the coil face instead of pulling through. Now, I will place a plastic tarp over half of the coil face. This will begin to force the air through the fouled area. And there you have it. As you can see, the foam is now pulling through the system much more effectively than before. By using this tarping method in the field, you can help drive the solution through these fouled areas of your coil, helping you break through buildup of biofilm faster and restore airflow more effectively. In this section, we are going to discuss when and how to implement a less viscous solution for pre-treating units that present a particularly high delta P, typically 2 inches or greater. Using a solution that is diluted with less enzyme allows the mixture to begin penetrating the coil's buildup prior to the main treatment cycle, while also reducing the risk of excess foam carrier on the supply side of the coil. I've already calibrated my blue box for this demonstration. For your setup, use a process we covered in the previous sections. First, fill the blue box with water up to the designated fill line. Next, introduce approximately 1 ounce from your 6-ounce enzyme packet into the water. This lighter concentration helps create a more watery consistency, limiting bubble formation while still ensuring solution migration into the coil. For this application, I've dialed the blue box back to a setting that produces the aforementioned thinner solution. We will now coat the coil, making sure to apply solution evenly across the entire coil face. Once applied, the solution should be allowed to dwell for approximately 10 minutes. This dwell period initiates the breakdown of impacted debris within the coil. After the time has elapsed, you may proceed directly into the full treatment process. On rare occasions, you may encounter a coil that is so heavily impacted that the enzyme solution is unable to migrate through the coil at all. When this occurs, it is important not to continue reapplying treatment in an attempt to force breakthrough. Doing so wastes both product and time without guaranteeing breakthrough. In these cases, the recommended procedure is to treat and walk away. You'll begin by applying a heavy, uniform layer of foam directly across the coil face. This should be a deliberate, slow application to ensure full surface coverage. Once the coil is fully blanketed, do not attempt to continue treatment. Instead, leave the solution in place and allow time to do the work for you. Return to the coil in 2 or 3 days to continue the process. During this period, the enzyme solution remains active within the coil, steadily breaking down biofilm and organic matter that are preventing airflow. Our enzyme technology continues to perform for up to 4 weeks after application. By letting the solution dwell uninterrupted, you reduce the thickness and density of the impacted buildup, making future treatment passes significantly more effective. When you return, the coil will often show visible signs of progress, reduced restriction, improved penetration, and in many cases, measurable improvement in pressure drop. This sets the stage for a successful treatment cycle without unnecessary product consumption. The key principle is patience. By applying a thick foam layer and walking away, you allow the enzyme to break down what mechanical forces cannot. This approach preserves efficiency, conserves resources, and greatly increases the likelihood of achieving full breakthrough on your next treatment. In this section, we will address a condition we at Blue Box refer to as a bubble storm. As you can observe on the supply side of the coil behind me, there is an excessive accumulation of bubbles. This is an undesirable outcome in the field. Bubble carryover on the supply side can compromise nearby electrical components and in some cases allow foam to travel into the duct system. We will review both the preventative measures to avoid this condition and the corrective actions to take if it occurs during treatment. The primary cause of a bubble storm is operating with solution that is too dilute. When the blue box is set to draw an excessive amount of water, the result is a lower viscosity solution. This lighter mixture moves through the coil too rapidly and turbulently, leading to premature volumization and bubble formation as it exits the coil. If you encounter this condition, there are several corrective options available. The most immediate solution is to open the access doors on the supply side. This allows the system to draw makeup air from the mechanical space, reducing the airflow through the coil itself. In many cases, this simple adjustment resolves the issue almost instantly. Another option is to implement tarping. By isolating the section of the coil experiencing the excess foaming, tarping reduces localized airflow, allowing the enzyme solution to settle and drain through the coil face in a controlled manner. In more extreme or sensitive applications, it may be necessary to shut the unit down entirely. In such cases, Allow approximately 10 minutes for the enzyme solution to settle and drain before restoring airflow and resuming the treatment process. In summary, proper equipment calibration and airflow management are critical to preventing and resolving bubble storm conditions during Blue Box treatments. That concludes our Blue Box training series. We started by reviewing the contents of the system and how to set it up properly in the field. We then walked through the best practices from trapping motors and coils to shooting the coil effectively for full coverage. We also covered what to do in more advanced situations, managing bubble storms, pre-treating coils with a high delta P, and handling extremely impacted coils with the thick foam walkway method. The key takeaway from this training is that every coil presents differently. Your success depends on understanding the condition you're facing and applying the correct method. By following these practices, you'll maximize the effectiveness of your Blue Box system, extend equipment life, and restore efficiency safely and consistently. Thank you for watching, and thank you for choosing Blue Box.